Hi guys, welcome back to another video. I'm Nero from ComfyUI AI, and today we'll be testing the newly released Flux 2 Klein models, and I'll be sharing a super fast download script to download the models on RunPod. So what's new with these models? We get super fast inference speed. The outputs are more photorealistic and diverse. Unified generation and editing in the same model, just like we got with Flux 2 Dev. Runs on consumer GPUs, and one of the models in this Klein series is Apache 2.0 licensed. Here are some examples showing the text-to-image capabilities of this model. Now, what models are included in the Flux 2 Klein model family? First, we have the Flux 2 Klein 9B model. It's a 4-step distilled 9 billion parameter model, uses Qwen 38B as its text encoder, and comes with a Flux non-commercial license. Then we have some image editing examples here, which look quite impressive. The other model in this family is the Flux 2 Klein 4B model. This is a 4 billion parameter model with an Apache 2.0 license. This model can be run on consumer GPUs like the RTX 3090 or 4070. It's also 4-step distilled and comes with both text-to-image and image editing capabilities. Next are the Flux 2 Klein-based 9B and 4B models. These are the base models from which the above 4-step distilled 9B and 4B models were derived. These models are undistilled, preserving the complete training signal for maximum flexibility, which makes them ideal for fine-tuning and LoRa training. The 4B base is Apache 2.0 licensed, and the 9B base is licensed under the Flux non-commercial license. Here we have a few more examples showing the output diversity of these models. This is the complete Flux 2 model family. We've got Flux 2 Dev, Flux 2 Klein 9B, Klein 4B, Klein base 9B, and Klein base 4B. Out of all these models, only the 4B models are Apache 2.0 licensed. So to access the 9B models, you'll have to accept the Flux non-commercial license first. Now coming to the ComfyUI repackaged files. This one is for the 9B models. Here we have the text encoder and the VAE. It uses Qwen 38B as a text encoder, coming in at 16 GB. For VAE, it uses the Flux 2 VAE, same as Flux 2 Dev. For the main model file, you have to go to the original repo and download it from there. It's 18 GB in size. Now for the 4B model, it uses the Qwen 34B model as a text encoder, coming in at 8 GB. It also uses the same Flux 2 VAE. The main model files for the 4B models are available in the ComfyUI repackaged repo, since these are Apache 2.0 license, and these models are less than 8 GB in size. Now let's head to RunPod and start testing and comparing these models. I'll go with an RTX 3090 and bump the storage to 80 GB and deploy it. I now have ComfyUI up and running. If you want to install ComfyUI on RunPod with a one-click installer, check the video in the I button. Now to download the model files, I prepared these 4 scripts for each model type. You can find these and the commands to run them in the video description. First, let's see how to use the script for the 9B base model. Open a new terminal, paste the command for this script from the description, and press Enter. It mentions the model type here and reminds you to accept the license first from the Hugging Face repo. Then you can get your Hugging Face token from this link, and as it mentions here, your token will not be visible when you paste it here. So paste your token and press Enter. Make sure you see this confirmation message here. Now it gives you 2 options. First is to download all the files, the main file, text encoder, and VAE. Second is to download only the main model file. I've added these options because the 9B models use the same text encoder, and both the 9B and 4B models use the same VAE. So you may already have those files and only want to download the main model files. I'll go with the first option since I don't have any files right now. It starts downloading the files. Now all the model files for the base 9B model are downloaded and saved to the ComfyUI models folder. I'll download the model files for the 9B distilled model now. Here as well, you have to follow the same process. Here, I'll choose option 2 since we already have the text encoder and VAE for the 9B model. Now it downloaded only the main model file and placed it in the ComfyUI models folder. Let's run the script for the 4B base model now. Here you get the same options as well, just without the Hugging Face token requirement. I'll choose option 1 here, since we don't have any files for the 4B models. It starts downloading the model files. The model files are now downloaded and placed in the ComfyUI models folder. Now I'll also run the script for the 4B distilled model and choose option 2. All the models are now downloaded to the ComfyUI models folder. I'll go to the ComfyUI models folder and place the main model files of the 4 models in the diffusion models folder, the Flux 2 VAE file in the VAE folder, and the QN38B and 4B files in the text encoders folder. In ComfyUI templates under the image section, you can find different workflows for the different versions of the Klein models, but I will not use any of these. I've prepared this pretty simple subgraph workflow for testing and comparing the text-to-image capabilities of each Klein model. I've divided it into 2 groups, non-distilled and distilled. We have some basic inputs here on the subgraph nodes. If we take a look under the subgraph, you can see it's a simple text-to-image workflow. If you want to use this workflow without the subgraph, click on the subgraph node and click Unpack, then you can use it normally. For testing the editing capabilities of these models, I've prepared another subgraph workflow. This one is also divided into 2 sections, non-distilled and distilled. Here are the subgraphs with load image and other nodes, and this is the main subgraph with all the options. I have the same sort of subgraphs for each model type here. If we take a look under the main subgraph, you can see it's also a pretty simple one. And if we look under the load image subgraph, first we have the load image node, then we have the image scale to total pixels node, connected to the get image size node, which is then connected to the height and width of the empty latent image node. Then we have the VAE encode node and the reference latent nodes, which are chained together with the reference latent nodes of the rest of the load image sections, and finally connected to the positive and negative conditioning of the case amper. If you want, you can unpack these subgraphs, rearrange them, and use them as a normal workflow. I made them into subgraphs so that everything remains clearly visible during our testing and comparison of these models. You can find these workflows in the description. Let's start our testing and comparison with text to image. Press R to refresh the node definitions and ensure the correct models are loaded into the correct subgraphs. For resolution, I'm going with our usual 1088 by 1440. I'm using 50 steps and 4 CFG, as suggested in their official diffuser's inference code. Under the distilled section, make sure to select the non-base version of the 9B and 4B models. For steps, I'm using 4 since it's 4-step distilled, and since it's distilled, we have to use CFG1. Now let's start testing. I'll start with the 9B base version, The main text-to-image feature of these models is photorealism, so here's our prompt for that. I'll bypass the rest of the subgraphs and nodes, and I'll run it now. Here is our image. The skin looks good, and it completely followed the prompt. Now let's test the 4B base version. I'll fix the seed from the last generation so we can truly compare it. Here's our prompt. I'll run it now. The 9B base model took 3 minutes to generate that image at 50 steps with 1080 by 1440 resolution on a 3090. You can get good results with 30 steps as well, but I want to see the maximum potential of these models, so I'm using 50 steps. Here is our image. The skin and hair look a bit plastic or too shiny, but not bad. Here is the difference between the 9B base and 4B base models. The 4B model took 1 minute 25 seconds to generate this image, as compared to 3 minutes on the 9B base model. Now the 9B 4-step distilled model. It messed up the hands, but the skin looks quite good for 4 steps, and it took only 5 seconds to generate. Now the 4B 4-step distilled version. This one as well messed up the hands, and the skin looks weird. Here are the images from all these models at a glance. The 4B 4-step distilled model generated the image in just 2 seconds. Here is our next prompt. I'll run it now. Here's the image. The skin looks good. The fingers are good. The bokeh effect it added looks perfect around her hair. Moving on to the 4B base model. Here is our image. It messed up the fingers. The image looks a bit smooth, but overall, not bad. Now the 9B distilled model. Here's our image. The fingers look correct, the skin looks good, and overall it's a good image. Now the 4B distilled model. Here's our image, and it messed up the fingers here as well, but the overall image looks good. Only the 9B base model was able to produce correct fingers for this prompt out of all these models. Now let's test a bit more complex prompt. Here is our prompt, and I'll run it now. So here is our image. As you can see, this prompt was for a 2x2 grid. The image looks great, and it completely followed the prompt as to where each image goes in the grid. Just has a bit of deformities here. Other than that, it looks solid. Now the 4B base model. This one as well followed the prompt correctly. The fingers look fine, but the strawberry looks deformed. We have the same deformities here as well. Now the 9B distilled model. The fingers and skin look great here. We don't have much deformity here compared to the base versions. Now the 4B distilled model. We get some deformities here in the hand and the strawberries. And here as well. Here are all the images at a glance. Now our next prompt is for an anime-style image. Here's our image, and it looks quite good. 4B base model now. This one looks too smooth and lacks detail compared to the 9B base model. The 9B distilled model now. This one looks very similar to the base 9B model. The 4B distilled model now. Okay, so this one as well looks quite similar to the 9B base, and not smooth looking like the 4B base. Maybe it was a bad seed for the 4B base model. Now we have a prompt for claymation style. I'll run it now. Here's our image, and it looks great. You can see the clay texture, and overall the image looks great. Now the 4B base model. It looks good, but as with all the previous images from this model, it looks a bit smooth and less detailed. Now the 4-step distilled 9B model. This one as well looks great and highly detailed. Now the 4-step distilled 4B model. This one as well looks highly detailed, but has a slight issue with the tail here. Here as well, only the 4B base model's image sticks out as less detailed. Maybe the seed I fixed here is bad for this model, or this model can't do styles that well. Now I have a text rendering prompt here, and I'll run it now. The text on the cap looks good, and it just messed up the O with U here. If we take a look at the prompt, here's the text it had to render. Coming to the 4B base model. It has quite a few mistakes on the board here, but the text on the cap is correct. Now coming to the 9B distilled model. This one surprisingly nails the text. Now the 4B distilled model. This as well has a few issues with the text on the board, but the text on the cap looks fine. Now let's test the image editing capabilities of these models. Here is our image editing workflow. I'm using 4 load image nodes here because the Klein models can handle up to 4 reference images at once. I've bypassed all the other subgraph sections for now, as we'll start with the 9B base model. First, we'll try and edit with a single image, so I'll go into these load image subgraphs and bypass the nodes in them. You have to bypass the nodes inside the subgraph. Bypassing the subgraph itself will not work. I'll go inside the first load image subgraph and upload our first reference image. Here is our image. We'll try to change the color of her dress to pink. Make sure you have selected the correct models according to the model name on the main subgraph node. Here's our image. It perfectly changed the color of her dress to pink. Here is a comparison. You can see it only changed the color and preserved the rest of the image. Now let's test the 4B base model with the same edit task. Here is our image, and the 4B model also worked perfectly, no issue. The 9B base model took 4 minutes to generate with 1 reference image, and the 4B base model took 2 minutes, so half the time as compared to the 9B model. The gen times will increase as we increase the number of reference images, and the image resolution also plays a big role here. Coming to the 9B distilled model now. I've done the same setup here as well. We only have to use 4 steps here since it's 4-step distilled. Make sure to select the 9B non-base model here. Here is our image, and it looks exactly the same quality as the 50-step image from the 9B base model. Now the 4B distilled model, same setup here as well. Make sure to select the 4B non-base model here, 4 steps here as well. The 9B distilled model took only 7 seconds to generate that image, and this 4B distilled model generated the image in just 3 seconds. Let's see how good it is. Okay, so this looks great, and the quality is similar to the 4B base model. Really impressive. Now let's test 2 reference images. I'll go inside the second load image subgraph and upload our second reference image. This is our second reference image. We'll try to put that woman in the first reference image here. I'll bypass the nodes inside the load image 3 and 4 subgraphs. I'll enter the prompt and run it. It perfectly placed the woman in this image, while maintaining her pose and other features. Now the 4B base model. The 9B base model took 6 minutes 38 seconds to generate that image with 2 reference images, versus 4 minutes with 1 reference image. Here is our image from the 4B base model. The woman looks fine and it maintained the pose as well, but it messed up the height. Now the 9B distilled model. It messed up the pose. The woman looks different, and she has an extra hand now. Now the 4B distilled model. The 9B distilled model took 12 seconds to generate the image with 2 reference images, as compared to 6 minutes for the 9B base model. Here's the image from the 4B distilled model. It maintained the pose, but the woman is even taller now. This image was generated in just 6 seconds. Let's try 3 reference images now. I'll upload a new reference image inside the third load image subgraph. Here's our image. We'll try to put this handbag in this woman's hand and put her in reference image 2. I'll bypass the nodes under the fourth load image subgraph. I'll write my prompt and run it now. Here is the image, and it worked, but the handbag looks slightly big, but the rest of the things look fine. Now coming to the 4B base model. The 9B base model took 8 minutes to generate that image with 3 reference images. Here is the image from the 4B base model. The handbag is just hanging midair, and we have the same height issue here. This was generated in 4 minutes. Now coming to the 9B distilled model. This one looks good. The handbag proportions also look slightly better. And it was generated in 18 seconds. Now coming to the 4B distilled model. This didn't work at all. The woman is massive now, and the handbag is not there. Maybe 3 reference images for this 4B 4-step model is too much. It was generated in 8 seconds. It's time for 4 reference images now. I'll change the reference image inside the first load image subgraph, and then the rest of the subgraphs. We'll try to make this woman wear this outfit and pose somewhere. I'll write my prompt and run it. Here is our image, and we got the woman's face correct, the dress is correct, and the handbag is also correct, but can't see the heels. This is because our first reference image is in 1:1 aspect ratio, and the width and height of the generated image is determined by the first reference image. And since it was in 1:1 aspect ratio, the generated image also followed the same aspect ratio, and getting a full body view in 1:1 is often hard. So I'll replace the first reference image with the dress image, which is in a preferable aspect ratio for our full body image, and replace the fourth reference image of the dress with the woman's face. And run it again. Here is our image, and now we got the full body image, and the heels are visible. The face, the handbag, the dress, and the heels all look correct. Plus, it followed the prompt precisely for a Mediterranean coastline view. Really impressive. It took 9 minutes, 43 seconds to generate this image. 4B base model now. It didn't work with this one. We don't have the handbag and the heels, but her face and dress look accurate, and the Mediterranean background is also correct. It was generated in 5 minutes. The 9B distilled model now. It gave us a full body image, messed up the handbag placement, the woman's face looks okay, the dress looks correct, the heels look correct, but we have this extra foot here. It was generated in 24 seconds. The 4B distilled model now. It didn't work as well. The woman looks kinda similar to the reference image, the dress looks correct, the handbag is not there, the heels look correct, but we have artifacts in the toes. And what is this pocket here? Only the 9B base model was able to handle these 4 reference images perfectly. This completes our testing and comparison of the Flux 2 Klein models. I think these are quite capable models, especially the 9B models, and the 4B models are a great choice for lower spec systems. It's nice to see small models that are so capable. I think Z-Image now has some serious competition. Let me know in the comments which one you prefer out of these. Once again, you can find these workflows and the download scripts in the description. If you want to support this channel, please use the link in the description to sign up for RunPod and use that account as your main account. You will get a random bonus credit of $5 to $500. So this is all for this video. I hope you found it helpful. If you did, please like the video, subscribe to the channel for more such videos and automatic installer scripts for RunPod. Share your thoughts and comments. This is Nero, and I will see you in the next one.